Hello everyone, my name is Jonathan Stenbeck and I'm going to be talking about head and neck planning in Eclipse for the 2017 Radiation Knowledge Plan Competition. And I'm just going to go over sorry, can I start over really quick? Someone just came by and to ask a question. Sorry about that. Hello?
Nathan?
Sorry, someone came by my office. Is it okay if I start over?
Yeah, exactly. Let's start.
Yeah.
Let's start off.
Hello everyone, my name is Jonathan Stenbeck and I'm going to be talking about head and neck planning in Eclipse for the 2017 Radiation Knowledge Plan Competition. And this is a head and neck case that's a nasopharynx that's put on by the radiationknowledge.org. And they're taking people from different planning systems, and the idea is to just talk about what we did and how we got to this place with our plans and sort of best tips and tricks to get good scores. So again, my name is Jonathan Stenbeck, and I'm a medical physicist at Greenville Health System, and we call it GHS here. And GHS, it's a kind of big campus. There's 7 LINACs, 7 physicians, 7 physicists, and 5 dosimetrists. And I've been a physicist for about 9 years, and I'm certified in physics and dosimetry. And outside of work, I've been married for almost 10 years, and I have 2 boys, a 3-year-old and a 3-month-old. And so for an overview of what I'm going to be talking about, I'm going to start with just an intro to the planning competition, what it is, what the goals are, and what the specific plan is looking at. I'm going to go over how to start a plan, focusing on isocenter placement, the beam arrangement, looking at the scoring metric and how to tie that into the initial optimization. Then I'll walk through an optimization process and then go through some of the fine-tuning to get extra points in a competition like this. So for the planning competition, an email went out announcing it, so that's always fun to see these, and it was going to be a nasopharynx case. And this year, one thing that was different was there were going to be multiple trial submissions, which it's great to get feedback and see what your score actually is, so you can see what areas to focus on. So that was a really nice aspect of this, so you could get instant feedback and then tweak your plan to try to get a higher score. There was a clinical and a fantasy planning category, so one would be what you're actually doing in the clinic to current patients, and then a fantasy one where you're just trying to push the optimization as hard as you can to try to get as high of a score as you can. And this was the second year for the Radiation Knowledge Planning Challenge, and the previous year was the inverse planned breast, which watching the webinar series on that was greatly helpful for our clinic, and it's actually we've used tips from that to actually shape how we treat our current patients, specifically the beam arrangements where you're using the jaws to block the heart, the isocenter placement, and then pausing till the coverage is achieved on your PTVs, which was something we had never heard from anyone at Varian. And once we saw that webinar, I almost didn't believe it until I tried it myself and went and grabbed other people to come look at what you could do just by pausing your optimization. And then one of the main goals of this is just it's an opportunity to learn. And so any chance we have in our field to learn more once we're out of school, it's just really good for us. And as a community, it helps people get better and ultimately it helps the patient. So starting a plan. So once the email went out, you download the data set and you can start to look at what you're actually going to be treating. And so there's a few different things in here that I'm going to talk about. The scoring metric, to sort of tell you where points are going to be coming from, looking at what targets you're going to be treating, because that affects the next 2 points, the isocenter placement and the beam arrangement, and then looking at initial problem areas, so detecting early on where you're going to need to make compromises, and then how that goes into starting your optimization. And so over here on the side, you can see this is just a screenshot of what was actually getting treated, the different targets, different contours, and it's a head and neck, so there's a bunch of normal tissues in there. And so the scoring metric, when you first look at it, it looks a little overwhelming, but once you submit a couple plans, you really start to figure out where points are coming from and which sacrifices you need to make to get more points. And so there's a few different things for the PTVs. You have the true PTVs and the planning PTVs. And so a true PTV would be like the PTV 70. So everything that is supposed to get 70 gray, But in this case, we're scoring it at 95% of the volume, receiving 95% of the dose. And so each of those PTVs are worth a decent amount of points. You can see them up at the top there. And then you have planing PTVs, which are, for instance, the PTV 63 minus the PTV 70. And so for those, you're focusing on the conformity index and the homogeneity index. So basically, you want to get the dose inside of the planing PTVs, very homogeneous, and have that dose not spill outside of it. And then once you start to look at this, you can see problem areas. And that really comes from normal tissues either touching or being inside of structures. So this one had some very tricky ones. The brachial plexus was really carved out of one of the PTVs, as well as the brainstem is abutting the PTV 70. So you think a brainstem, you don't want 70 gray going to it, so it gets a little tricky when you're trying to cover something with 70 gray, but also spare a target next to it. And you can also look at where's there going to be a lot of dose spillage. So in order to treat a target by not treating a normal tissue, the dose has to come in from somewhere. And so you try to smartly shape that to just get the best coverage possible while sparing as much tissue as possible. And so how can you best conform the dose to targets is a lot done by the beam arrangement and the isocenter placement. So one thing I really like to do on head and neck techniques when you have long node chains is doing almost a half beam block. So if you were to look at these beams I've used below, you can see one of the jaws is closed. And this is a similar technique that was used in the webinar from last year's radiation knowledge planning competition, where one jaw would be closed and the arc would rotate around to spare something like a heart. So if you put an isocenter here and close the jaw in, as you rotate around, you're not going to have a lot of spillage between the node chains, which helps with the conformity index as well as covering or sparing the normal tissues between nodal chains. And so these two beams are kind of complementary beams. One's covering one side and rotating all the way around, and one's covering the other side and rotating all the way around. And there's a little bit of overlap between the two beams. And then we were allowed to use 4 beams on this plan, so I used one with a collimator of 90, and then just one other beam that really wasn't necessary. I just put it in because the more beams you can use, why not? And the isocenter I placed here, I centered superior, inferior in the main PTV 56 so that you get a similar Y jaw in each direction. So this is about plus or minus 15 centimeters for each Y jaw. And so fixing a jaw is something that you might not even know you can do in Eclipse, but before you optimize a plan, if you type in a jaw coordinate in the optimization, that'll be the maximum position that jaw will go to while optimizing. So for instance, when I initially ran this plan, for the beam on the left, you can see the X2 jaw is stuck at 1. So I would just type in 1 and then the max position for the other jaws. And so jaws can close during the optimization, but they can't open up past what you initially typed in. So that's a decent trick that you can use to kind of help spare things. And so to actually start the optimization, I kind of do it in phases. I start with PTVs and make sure those are covered and then bring in normal tissues. I know that's different than some people do, but I just find it works well for me. And so what I'm going to go through here is a plan from scratch that goes through 2 optimizations and gets a pretty decent score. I'd say it's like a low 90s for this planning competition. And so what I'm going to do here is I'm going to start with just the PTVs. You have each of the true PTVs and then the planning PTVs. And I have lowers on each of the PTVs, the true ones, to where you're going to make sure you get enough coverage to get all the points there. And then for the planning PTVs, you can see I have uppers as well as lowers to try to get a nice homogeneous dose on those. And this doesn't take into account any of the spillage outside of the PTVs yet. I'll do that in the next step. And so just to sort of show you an actual optimization, I took some screenshots at different times. So using those parameters and just waiting, you can see over time that the PTVs get more and more homogeneous and better covered. And so I let it go normally to MR1 step 3 before I start bringing in my normal tissues. So right here at about 30 minutes. I think I actually had to walk away and go see a patient, so it definitely flatlined for a while there. But one thing that is interesting to look at is back here at the beginning, it almost looks as if the cost function, the black line there on the bottom, has leveled out. But if you just pause it and let it wait, and this is something I learned from last year's planning competition, it'll continue to improve and your targets get better covered if you just keep waiting. And so that's something we do on our patients now that we never knew was really possible until the competition last year. And so about right here is where I would start folding in my normal tissues. So again, I probably wouldn't have waited 30 minutes, but I had to go do something else, and so in that time, it definitely leveled out. And so for bringing in my normal tissues, I would do that in step 3, and for the sake of this competition or this webinar, I initially just gave everything a priority of 50. So I looked at the scoring metric and just made all the dose constraints a little bit below where they need to be and gave them a priority of 50. And so if there was a mean or an upper, I just really typed that in here. You can see I have 1 constraint per normal tissue. There's really nothing fancy going on here. And I just started with a priority of 50. And I would up it as needed, and I'll talk about that in just a second. So here's some screenshots of that. So MR1 step 3, you can see the spike here from where I typed in all of my normal tissue values. And then I just let it run for a little bit and start leveling out. So initially, everything is on. All the normal tissues that we're supposed to spare are in this window. And then after about 15 minutes, I look and see which ones are not being met. And you can see these here. There's the lenses, the brachial plexus, the parotid, the brainstem, and a couple others. I think that's the posterior neck and one other. And so I would just up the priority of those a little and continue to pause and let it run. And you can see the coverage is getting a little bit worse on the PTVs, but that initial phase of letting it run for 20, 30 minutes really helps the coverage stay pretty tight like this while you're doing your normal tissue part of the optimization. And so here's just some screenshots over time. And again, you can sort of see where I had to step away and go do something else because I wouldn't normally let this run an hour, but I was doing this while at work, so it was running in the background. And you can see normal tissues are getting a little bit better covered, and it did its intermediate dose calc, and then I pause it again to let it run. And so at this phase, there's really not many normal tissues that aren't met, which when you see that initial list on the scoring metric, there's a bunch to spare there, but you cannot actually spare most of them. And so here I'm just looking at the brainstem and the left parotid, and then I let it do its final calculation. And so after that final calculation, I'll go in and evaluate the coverage versus the constraints from the scoring metric. And one thing you could do is if there's doses overlapping structures you're wanting to get rid of, you could create dose contours to help with that, to do like a more of a focused optimization. And then once I figure out what areas I'm going to need to tweak and adjust a little, I'm going to restart my optimization, but I'm going to continue. I'm not going to start over. And I'm going to go back to MR3 and pause it. And then I'm going to start to raise the priorities or lower the dose constraints for the remaining structures that I need to get better coverage on. And then I'm going to raise also the priority and increase the dose constraints for the PTVs to get better coverage. Because when you go in to normalize your PTVs, you might have to normalize to a lower percent to get better coverage, which will in turn raise the dose to your normal tissues. So increasing the coverage on your PTVs helps you not have to normalize as much, so that when you're looking at your optimization window, that's a more accurate representation of what you're going to see in the end. And so when I went and evaluated my PTV, there were three normal tissues that weren't very well covered, so they would have been pretty far outside of the scoring metric. And so that's the brainstem, the brachial plexus, and the left parotid. And all of these are either touching or inside of PTVs. And then also the PTV70, if I increase the coverage, I wouldn't have to normalize it as much. And so going back in, these are going to be the 4 areas I focused on. And so again, I'm going to slowly raise priorities on the constraints until you start to see the cost function change. And I backed up to MR3, and then if it was a really small change, I would have only gone to MR4 to make adjustments. And end capping is something I'm going to talk about in just a second. So here's my optimization, the optimization run 2. You can see the parotid, brachial plexus, and brainstem here, and the PTV70. And the red line on the bottom, you can see where I up the priority of the parotid because it's spiked, and then it starts to lower down. So the goal there was to get 50% below 30 gray, which it starts to. And the brainstem, you're trying to get it below, I think, 54, 55 gray for the brainstem PRV. And then the brachial plexus, and you're wanting to get below 63. And you can see, again, I had to go do stuff, so it ran for over an hour, but this only needed to be about a 15, 20-minute optimization. So as I raise the priorities, those come into tolerance of what we're using for the scoring metric. The PTV70 has a nice sharp shape to it and is getting coverage at the 6650 centigray, which is where we're trying to prescribe to. And so I would let this finish up and calculate, and then I would go over here and look at my final DVH. And so again, this is a plan that's only run through 2 optimizations, and it should take about an hour and a half or 2 hours to do something like this. And almost all of the normal tissues would meet the scoring metric that you would see in for the plan challenge, as well as the homogeneity and the conformality would be fairly nice. So in terms of the first few plans I submitted, they were similar to this. And then for the further optimizations, you're really just looking at pixels here. So you're not looking at big clinical gain, but for the sake of a planning competition, it's kind of fun to try to get a really high score. And so you focus in on small pixels or voxels and try to get doses just right. But one thing people might have noticed when they were submitting things is that normal tissues they saw covered on their DVH correctly, you might see a different dose printout when you're looking at the Sun Nuclear Plan IQ. And that comes from a thing called end capping, where in Eclipse, the DVH is underestimating the true volume of the structure. And there's different fixes for this, and all of them are just kind of hand-waving ones to try to get things to agree, where you can expand your contours in the superior-inferior direction. But this definitely can cause some confusion. It did for me the first time I saw this in one of these plan challenges. But supposedly end capping is going to be fixed in a later version of Eclipse, but it's still something you have to deal with when you have small volumes and you're trying to get doses shaped precisely to the contours you see. And so after about 2 hours of time, I would say you could get a decent plan using the constraints and priorities that I have in this presentation, where you could get a score of roughly 90 or so just by doing those things. And in terms of some final thoughts on this, I'd say getting a score of 97 versus 99 in the competition has very little difference clinically, but requires a huge amount of time. So the first plan I submitted was just a few runs, but then I spent 3 or 4 weeks getting up to a 99. So was that a great use of time? I don't know, but it was a challenge for me, and I feel like I learned a little bit more about Eclipse in that process. But one of the main points is improving a score from, say, 70 to 90. It actually will make a difference clinically and requires very little time. What it does require is some initial thought in the plan. So how you're going to set it up, what beams you're going to use, and then smartly using the optimizer to meet the goals you're trying to get without confusing the optimizer, and just making sure what it's trying to optimize is actually what you're trying to achieve. And in general, that's the goal of this planning competition and other ones. It's trying to share knowledge and help everyone improve to kind of bring scores up to a good score. And so I wanted to just say some thanks to Ahmed. I mean, this is just a large amount of time to spend on any project, and so he did a great job this year just communicating with everyone, scoring plans and emailing you back normally within an hour, even if you're on the other side of the world. And then just all the other people in the committees responsible for organizing this plan competition. And then if anyone has any questions or comments about this, please, you can send me a direct email at jstenbeck@ghs.org. And then the Radiation Knowledge website is just a great place to find some videos. Again, if you haven't seen the one on inverse plan chest walls or breasts, you should look at that one from last year. It really helped our practice, and it's just a great place for knowledge and sharing that. So thank you very much, and that's it.
Thank you very much, Jonathan, for your informative presentation. I really enjoyed it. And just let me first congratulate you for your newborn baby, Jackson. He was born during the competition, I think, right?
Yep.
Yeah. And just as a side comment, Jonathan scored, as he mentioned in his presentation, he scored 97 from his first submission, and within I think four submissions or 5 submissions, he could reach 99, which is really a great achievement actually. And I hope after this presentation, planners found it useful. And in case if any planner has any questions, either he can contact Jonathan, or he or she can write their comment or their question in the comment tab of this YouTube video, and we will do our best to answer his or her question. The answers will be provided by the top planners. We'll try our best to remind them, and we'll try to answer your questions. So thank you very much, Jonathan, for your presentation.
Yeah, you're welcome.
Thank you.